So everyone, let's continue with question 21 onwards of the same paper, which is 2020, paper 1, May June. So question 21 says, which aqueous reagent liberates ammonia from ammonium nitrate on warming? So ammonium nitrate is NH4 NO3, and we should know that ammonia is released every time when some alkaline substance is added over here. Now we got to find which one is an alkaline substance. Calcium nitrate is a very neutral salt, so not an alkaline substance. Potassium hydroxide, highly alkaline. Sodium chloride, a neutral salt. Sulfuric acid is an acid, obviously. So potassium hydroxide liberates ammonia gas. Two fertilizers are made by mixing chemical compounds. Fertilizer X contains 500 grams of ammonium nitrate, 500 grams of ammonium sulfate per kg. Fertilizer Y contains 700 grams of ammonium nitrate and 300 grams of calcium sulfate per kg. So let's try to find out. They're saying which fertilizers contain the higher percentage of nitrogen and which contains the higher percentage of sulfur by mass. So it's a rather longer calculation. So let's break it down. First, let's do fertilizer X and let's find the percentages of nitrogen and sulfur over here. Nitrogen is going to be 500 times, now ammonium nitrate has two nitrogens, so 28 divided by the molecular mass, which is 80. That is going to give us the mass of nitrogen contributed by ammonium nitrate, plus we're going to be doing 500 times ammonium sulfate as again two nitrogens because there is two outside the nitrogen bracket, so again 28 divided by ammonium sulfate's molecular mass 132, and then we're going to divide it by 1000 to find the percentage. So 28 divided by 80 times 500, 175, plus 28 divided by 132 times 500, 106.06. This is the total mass of nitrogen over here. Let's divide this total mass by 1000 and then find the percentage. So we are going to divide it by 1000 because they're saying 1 kg. The percentage then multiply by 100 turns out to be 28.1% nitrogen. We do similar stuff for calcium. So in case of sulfur, what we're going to do is first fertilizer has no sulfur at all. The second fertilizer, obviously, which is ammonium sulfate, let's do that. It has only one sulfur, which is 32, divided by 132 times 500. So it's going to be 32 divided by 132 times 500. This is the total amount of sulfur. Let's divide it by 1000 and multiply it by 100. So we're going to get the percentage to be 12.12. So 12.12% sulfur is in fertilizer number 1. So this was for fertilizer X. Let's go for the second set of calculation. I know it's a little longer, but when we have our process in our mind and we are good with the calculator, we're going to be doing it really quick. Let's do for the second one 700 times 28 over 80, and then the second fertilizer has no nitrogen at all. So we're going to get the amount of nitrogen from the fertilizer Y, ammonium nitrate. So it's going to be 28. There's only one there are two nitrogens, so 28 divided by 80 again, and then times 700. So it's 245. 245 divided by 1000 times 100. So it's going to be 24.5% nitrogen in fertilizer Y. Let's go for the second fertilizer. It's calcium sulfate. This time it has again one sulfur, which is 32. Calcium sulfate is 136. And what is the mass over here? It's 300. So we're going to go 32 divided by 136 times 300, and then we divide it by 1000 and then multiply 100 for the percentage, which is 7.05. So 7.05% sulfur in fertilizer Y. Nitrogen was present as 28.1, in fertilizer X. So X has more nitrogen, either A or B. When we go for sulfur, again sulfur is again present more in fertilizer X. So we're going to go for option A for apple because X contains more amount of both substances. Let's go for the other questions. Which processes occur in the manufacture of sulfuric acid? Burning sulfur in air, yeah, that is true. You burn sulfur in air to get SO2. Dissolving sulfur dioxide in sulfuric acid, that is wrong. You don't dissolve sulfur dioxide, you dissolve sulfur trioxide, and not even dissolve, you mix it with sulfuric acid. So that is wrong. Dissolving sulfur dioxide in water, you don't dissolve sulfur dioxide in even water. Reacting sulfur dioxide with air, that is the main reaction of contact process to produce sulfur trioxide. So 1 and 4 is the only option that is correct. A lump of element X can be cut by a knife. So either sodium or potassium, mainly because they are easily, they can easily be cut by a knife. During its reaction with water, X floats and melts. It floats means the density is lesser than one which is water. It is obviously potassium. Chlorine is passed into separate samples of aqueous potassium iodide, which is Ki, and aqueous potassium bromide, which is KBr. In which solutions is there a color change? So chlorine can displace potassium iodide and produce iodine. Chlorine can also displace bromine from potassium bromide because chlorine is more reactive than both. So A for apple is the answer. Chlorine can displace both. Which diagram shows the structure of an alloy? Alloy means a mixture of metals, perhaps with other non-metals, so they have differently sized particles. B seems to be graphite because it has layers. C is more likely to be an ionic lattice. And apparently D has all the same size particles, so it is mostly a pure metallic lattice. Which element can only be extracted from its ore using electrolysis? It is true for highly reactive metals. Because highly reactive metals are very high in the series, they do not get reduced either by carbon or by hydrogen. So it has to be something which is very high in the series, calcium. Especially the molten ore. You use molten ore of calcium, you don't even use aqueous substances. Which equation shows a thermal decomposition that occurs in blast furnace? So thermal decomposition is something in which when one substance, breaks down into two or more. Option A is actually a combustion because it's reacting with oxygen. Option B is actually a reduction because it is reduced by reaction with pure carbon. If you have watched my video, it's over there. That is purely decomposition, that is thermal decomposition of calcium carbonate. So C has to be the answer, while option D is a neutralization because calcium oxide is alkaline, silicon dioxide is acidic, and you get slag over here in option D. That is why C for cat is the right answer. Which diagram correctly shows the conditions necessary for the rusting of iron and also the metal that can be used to prevent rusting by sacrificial protection? Conditions necessary for the rusting of iron include water, oxygen, and sometimes acidic environment. The metals which are good for protection are all the metals which are higher than iron, like magnesium, like zinc, sometimes aluminium, but aluminium protects itself by the oxide layer. So let's go for it. Option A does not have water, so water isn't here. Option B again does not have water, so can't rust. Option C and D are both good, but copper does not prevent iron from rusting, only magnesium does. So D for doctor is the right answer. Aluminium is produced by the electrolysis of pure aluminium oxide. Aluminium oxide looks like this, Al2O3, and it's used in liquid state. One of the electrodes in the process has to be replaced often. Which statement is correct? The product at the anode reacts with the anode. The product at the anode reacts with the cathode. That doesn't make sense. Why would it react with cathode? The product at the cathode reacts with the anode. Again, doesn't make sense. Why would it go to the anode all the way? The product at the cathode reacts with the cathode. Now, the product at the cathode is pure aluminium in the liquid state. The product at the anode is the oxygen gas. Anode itself is made up of carbon graphite. So actually, the product at the anode reacts with the anode. So option A for apple is the right answer. Which row correctly compares carbon dioxide and methane? Both contain carbon. Let's write the chemical formula CO2 CH4. Both contain carbon, yes. Both are described as a greenhouse gas. Yes, both are greenhouse gases. Both lower the pH of water when they dissolve in it. So carbon dioxide is acidic, but methane is neutral. So carbon dioxide decreases the pH, but methane doesn't. So B for Barrows is the right answer. They're both containing carbon, they both are greenhouse gases, and they both don't lower the pH, only CO2 does. Seawater has to be purified in order to obtain drinking water from it. Which processes are used to purify the seawater? Fractional distillation. Fractional distillation can do that, but you need to keep in mind that fractional distillation is used for substances with two fluids or more with different boiling points. Desalination involves removing the salts. So when we talk about fractional distillation, water does not have various liquids over here. Water is just one liquid, and the other substances are mainly dissolved solutes, bacteria, and some undissolved bigger substances. So when we talk about seawater, we are concerned with salt removal, so that has to be desalination. So C for cat is the right answer. Fractional distillation can be done only when there are two liquids or more liquids with different boiling points. Which structure represents an isomer of butane? Butane is C4H10. So let's look at the structures. Option A is a straight chain, unbranched straight chain. I've mentioned this many times that a branch from the corner is not counted as a branch. Option B is again straight unbranched, because again a branch from the corner is still not counted as a branch. Option C seems to have a branch because it's from the center. It is isobutane. More appropriately, we can call it 2-methylpropane. You don't have to know the name, but you should know that it's a branch from the center. And option D is not even butane, it's called cyclobutane. That's why C for cat is the right answer. So question 34 says, which statement about the organic compound CH4, C2H4, C2H6 and C3H8 is correct? Only C2H4 and C2H6 decolorize bromine water. C2H4 is an alkene, I know that. But C2H6 is not an alkene, it's alkane. That is why it won't decolorize the bromine water. They are all saturated compounds. I mean, CH4 is, C2H6 is, C3H8 is, but C2H4 is ethene. It's not a saturated compound. They're all unsaturated compound. Again, not true, because the other three are saturated. They're all hydrocarbons. Yes, they are all hydrocarbons because they have hydrogen and carbon in their molecules. The alkenes are a homologous series. Which statement about the alkenes is correct? An alkene molecule contains 4 fewer hydrogen atoms than an alkene molecule with the same number of carbon atoms. That is not true, because C3H8 and C3H6, comparing the number of carbon if same, hydrogens are only 2 less. So that's not a difference of 4, it's a difference of 2 units. If a food is described as unsaturated, it means that it contains polymers. That is so not true. Polyunsaturated means many carbon-carbon double bonds. Propene reacts with steam to form propanol. That is so true, because if propene C3H6 reacts with steam, it produces C3H8O, which is propanol. The general formula for the alkenes is CnH2n plus 2. That is wrong because this is the general formula of alkanes. Which organic compound is used as a solvent, a renewable fuel, and in the production of vinegar? So that is going to be ethanol, because ethanol is a good fuel, it is a good solvent, and it can be oxidized. Ethanol is oxidized to make ethanoic acid. So it is going to be ethanol. So guys, let's read question 37. It says, which structure shows the carboxylic acid with the lowest relative molecular mass? So it's got to be a carboxylic acid, and it needs the relative molecular mass to be the lowest. C is not a carboxylic acid, D is not a carboxylic acid. It can be either A or B. You can see A has lesser atoms total. This is a carboxylic group and it has lesser total atoms. So obviously A has lesser relative molecular mass. What is the name of the ester shown? You need to see this is the ester group. This side over here is the acidic side because it has the carbon double bonded oxygen over here, and this side is the alcoholic side. The acidic side has 4 carbons and the alcoholic side has 3 carbons. So it is going to be propyl because the alcohol is propanol, and butanoate, propyl butanoate, because the acid is a 4 carbon acid. So it's going to be propyl butanoate, B for Barrows. The diagram shows the structure of a monomer. Which diagram shows the partial structure of its polymer? So you need to realize the 2 carbon atoms with the carbon-carbon double bond are here. You can see this carbon, the one on the left, has F on one side and CH3 on the other side. So it is going to be having F on one side, which is fluorine, and CH3 on the other side. The other carbon you can see has H and Cl. So it has H on one side and Cl on the other side. So it has to have a repeating unit of F with CH3 and H with Cl. So you can see this is not it because it has no CH3s represented. Option C has Cl and F on the same side. That is wrong. You can see option D has fluorine and CH3 on the same side, while it has H and Cl on the same side. So D is the right answer because F and CH3 should be on the same carbon, H and Cl should be on the same carbon. Which statement about polymers is correct? Nylon and terephthalene are produced by addition polymerization. That is so wrong because they are both condensation polymers. Nylon and terephthalene both contain amide linkages. No, sorry. Terephthalene is a polyester with ester linkages. Simple sugars are produced by hydrolyzing proteins. No, sorry. When proteins are hydrolyzed, they give amino acids. Starch contains the elements carbon, oxygen, and hydrogen. That is so true because starch is a polymer containing sugars which have carbon, hydrogen, and oxygen. So these are the MCQs that we tried over here. In the next video, we'll try something else. Stay tuned, guys.